anything too crazy today. So first part, let's just talk about all of these definitions. Not something that I'm going to give you a test and ask you to write the definition or even match the definitions. These are just words that I might say, so I want to make sure you have some idea what I'm talking about. Okay, so I'm not actually going to assess this part. What am I talking about if I say a line? I typed the definition on your sheet, but do you know without looking at that?
Like a line between 2 points.
Okay, so you have 2 points. Does it stop or does it keep going?
Keep going.
Okay, so it said defined by 2 points A and B. It basically goes through both of those and keeps going. You might see it written as line AB. We're not going to see this a lot this semester. You know, I might show a couple times, but just kind of a refresher. Also good for ACT stuff, just making sure you know those notations. What's a line segment? Stops. It's just a segment connecting A and B. Shorthand for that is just an AB with a little line segment over the top. If I say ray AB and it's written like this, what does that mean? Starts at A, goes through B and keeps going. So a ray essentially has one endpoint, keeps going the other direction. You guys remember these? I've seen all those. Okay. The thing that we are going to do a lot of in trade, we're going to talk about angles a lot. That is one of our main emphasis. So in talking about an angle, the definition I typed on your paper just says 2 rays with a common endpoint. So they have the same endpoint and 2 rays extend. The difference, you've seen the angles before. For now, our angles will have an arrow drawn on the inside as well. That's going to tell us which way the angle is turning. So in this, if I'm talking about the sides of my angles, what do you think I mean? Yeah, the 2 rays. Those are the sides. So this is the side, and this is the side. What's the vertex? Yeah, that point, common point they share. We have an initial and a terminal side. So initial means beginning. The way I have my angle drawn, you look on the inside. Which one is the beginning side here? Bottom or the top? The bottom. So this is my initial side. And that's my terminal side. Even these terms with the angles, I'm still not going to use this a lot. I'm probably not going to, put it on a test and say label the vertex, initial, and terminal side. But I just want to make sure you have some idea of what I'm talking about if I mention those things. Now, I want to get into this angle itself. When I draw the arrow, that has a meaning because unlike in geometry, we are going to talk about positive and negative angles in this class. And that is all determined by your direction inside there. So let's draw a couple pictures. I'm going to draw 2 identical angles. But I'm going to draw a different inside. One of them is turning this way, and one of them is turning this way. This one is a positive angle. Is that turning clockwise or counterclockwise? Counterclockwise. So counterclockwise is a positive. This is considered a negative angle. This one is turning clockwise. Another example for positive and negative. Even if I'm looking at these same pictures, you don't have to just be talking about that inside angle. I might say this top is the initial side, and I'm spinning around to the bottom. Okay, or a negative angle might be starting here and going around this way. So that arrow is going to be very important to us. It tells us, first of all, which direction, so we know if it's positive or negative. Second of all, it could be inside or it could be outside. So when we're talking about the measurements of the angles, that placement is very important. Questions so far? Talking about angles, you should know the different types. So what's an acute angle? And I already typed this for you, but between 0 degrees and 90 degrees. And you need to have that 0 there because now we're dealing with negative angles. So negative 270 degrees is not acute. You can't just say less than 90. It's a positive angle between 0 and 90. What's a right angle? Obtuse? I'm just going to say greater than 90. But one particular, what is a straight angle? 180 degrees makes a straight line. So we're okay with all of those. We've seen those definitions before. Complement and supplement. Remember those? What's complement? Add to 90. Supplements add to 180. If you have trouble remembering that, C comes first in the alphabet, so it adds up to the smaller amount. Complements add up to 90. Supplements add to 180. So there's our first little geometry review. I want to do some practice problems with some of this stuff. I did not type these examples. I think the back page is blank on the notes, so if you want to flip there, there might just be one example on it. You can do some of these on there. Just want to make sure we know how to work these. So if I told you your angle is 55 degrees, find the complement and supplement. I'm going to let you guys do that one on your own. All right, so complements, you might be able to just do it in your head. If you had to show some work, you know that complements add up to 90, so you just have to do 90 minus 55, and you get 35 degrees. I am going to be a little bit picky. I do want you to make sure you're putting your degree symbol. It's going to be a while, but eventually we're going to get to another measurement that doesn't have a unit. And so at that point in the class, if you write at 35, it would be radians and not degrees. So I just want you to get in the habit now of putting a degree symbol anytime we're talking about a degree. Supplements add up to 180. So just 180 minus, I can't write today, 55, and that gives you 1.5. So, okay with that? What if I give you this picture? Could you find the measure of each angle in this? Do we know anything else?
Two come together.
Yeah. Remember that box is a right angle symbol, so that means if you add those, they have to equal 90. divided by 5, 18. I asked for the actual angles, so 2 times 18 is 36 degrees, 3 times 18 is 54 degrees. Any questions on that one? I'm going to give you guys one then. Find the measure of each angle in that picture. Straight angle. We know straight angles add up to 180. Straight line. Divide by 9, so t is 20. So your angles are 140 degrees and 40 degrees. So far, so good? Just a notation thing. You will see me, if I'm talking about an angle, when I want the measure of it, if I have a name for an angle, let's say I call this angle A, I might write the measure of angle A like this. That lowercase m just represents the measure. So just be prepared. I will probably ask that a lot of times versus writing out, find the measure of this angle. Okay. So now we are going to get into something new. I don't think I'm quite ready to go back to the notes yet because I didn't type up everything. So if you could bear with me, you're going to have to take your own notes for just a few minutes. We sometimes need to be more accurate than just going to the nearest whole degree. For instance, if you, a career that uses trig, be like a land surveyor, and their measurements have to be very, very precise. When you get the, description of your boundaries on your land, you don't want them saying, oh, it's about 34 degrees this way. You want it to be exact. And so to do this, they use a notation called degrees, minutes, and seconds. So we've seen decimal degrees before, 24.5 degrees, that's nothing new. But degrees, minutes, and seconds is another notation that's often used. In that, when I am talking about 1 degree, it's just like in time. 1 hour is 60 minutes, so 1 degree is 60 minutes. The notation, a degree symbol, we know what that looks like. A minute symbol is 1 tick mark. So 1 degree is equal to 60 minutes. We know 1 minute is 60 seconds. And that's still true here. 1 minute, 60 seconds. So we write 1, a minute is a tick mark, seconds is 2 tick marks. So if I want to be more precise, I can give you a measurement using degrees, minutes, and seconds. Since I can also give it to you in decimal degrees, we're going to have to be able to go back and forth between the two. Before I start converting, I want to do some problems just working with minutes and seconds to have you practice adding and subtracting with those, and then we'll get into the conversion piece. Okay. So let's look at this problem. So if I wanted to add these, without me telling you how to add them, what do you think you would do? Yeah, add the degrees and add the minutes. That's exactly what we're going to do. If it helps you, you can write them, stacked, like they taught you back in elementary when you were working out addition problems, if you stack them up. But essentially, all we're going to do, we're going to add the minutes together, get an answer, and we're going to add the degrees together and get an answer. So if we do this, how many minutes would we end up with? 87 minutes, and my degrees, so we get 91 degrees, 87 minutes. Okay. Now, if you are going to, telling somebody how to get somewhere. Okay. Do you say, oh, it'll take you 1 hour and 87 minutes to get there? No. What would you say? 2 hours and 27 minutes. So if my minutes are bigger than 60, we're going to rewrite this. When I get 60 minutes, that turns into a degree. So that would make it 92 degrees. If you took away 60 minutes here, 27 minutes. And that's our final answer. Did I confuse anybody right there? I'd like to do a subtraction and then give you guys a couple to try if that's okay. For the subtraction, I'm going to go ahead and write this as 180 degrees minus 117 degrees, 29 minutes. Okay, so if you think back to elementary, this is like 180 degrees, 0 minutes. What do? Can you do 0 minus 29? No, so what do? Borrow. Now, if I take away 1 degree, this becomes 179. Does that give me 1 minute over here? No. 1 degree is how many minutes? 60. So this will bring over 60 minutes when I borrow. Now we subtract. 60 minus 29, 41 minutes. 179 minus 117, 62 degrees. Everything okay with that? You guys should try these. Okay, so the first one, add your minutes. 29 plus 57 gives you 86 minutes. 72 degrees. Is that okay for your final answer? No, since it's bigger than 60, you take away 60 of those and turn them into a degree. So you get 73 degrees, 26 minutes. Okay, the subtraction. Careful. I noticed a couple of people had a mistake here. Your book is going to write 04. You can just put 4 minutes, whatever you're most comfortable with. It doesn't matter. If you don't have anything above it, that's like 0 minutes. Can you do 0 minus 4? No, so we do have to borrow again. That's 119 degrees, and it brings over 60 minutes. So 60 minus 4 is 56. 119 minus 101 is 18 minutes. 18 degrees, 56 minutes. Okay with everyone? Now I'm going to go back to your handout where we left off. So let's talk about the conversion. On your handout, I tried to break down and give you steps. It kind of makes more sense, especially if we're learning it, just working through a problem. When you're converting, if you look at this, to convert to decimal, the degree part isn't going to change. So it's still going to be 105, but now it's going to be point something. So you're not going to change the degree part. To change the minute part, there are 20 minutes. How many minutes are in an hour? 60. So this is like 20 out of the 60 in an hour. So we still have our 105 degrees. We have 20 out of 60 minutes. Now your seconds. 32 out of how many seconds are in 1 hour. 3,600. 60 seconds in 1 minute, so 60 times 60. So what you're going to do, you don't touch the degree. Minutes divided by 60, seconds divided by 3,600. We're just going to add all that together so you can put it all in your calculator. Nearest thousandth is how many decimal places? 10, 100, 1,000. So 3 decimal places. So I got 105.342 degrees. To go the other direction, think about, to get the decimal, you divide it. So the opposite of dividing would be multiplying. So what we're going to do, again, the degree part isn't going to change. We are going to take the decimal portion, so I have 0.263 of a degree. If I want to find my minutes, I just take that times 60. Go ahead and calculate that. All right, and you get 15.78. This is your minutes. So right now I have 85 degrees. If I wanted to take this, I have 15 minutes. If I want my seconds, I have 0.78 of a minute. If I want to change that into seconds, how many seconds are in a minute? 60. So we're just going to take the decimal part times 60 one more time. It's 46.8 seconds. We'll just round to the nearest second. So that would be 47 seconds. So 85 degrees, 15 minutes, and 47 seconds. I want you to try one of each on your own. I put them on your handout, and I even put the answer there so you'll know immediately if you got it or not. So try your conversions for me. We did 8 out of 60. 14 divided by 3,600. And nearest thousand, 3 decimal places, so you get 74.137 degrees. Second one, we know it's 34 degrees. To get your minutes, you take your decimal times 60. You get 49.02 minutes. So that's 49 minutes. To get your seconds, you have 0.02 of a minute. Take that times 60 and you get 1.2 seconds. So that just rounds to 1 second. Still okay? I think I'm going to do one last definition, then I'll probably stop there for today. That's okay. The last thing I want to talk about today is coterminal. If I'm talking about a coterminal angle, that means it ends at the same spot. For instance, if I had we all agree this is like 0, 90, 180, 270. This would be 360 if you keep adding 90. Are you okay with that part? So if I drew this angle right here, that angle would have a measurement, let's say approximately 100 degrees. An angle coterminal with that has a different measure but ends at the same spot. So a coterminal angle might be one that started here as well, went all the way around, and then came back. The measurement of that angle, you went all the way around, which is 360 degrees, then traveled another 100, so that one would be like 460 degrees. They have a different degree measurement, but when you're drawing them, their terminal side is the same. They end at the exact same spot. Okay? Another one might be if I started here, but I went this way. If I go this direction, what kind of angle is that? A negative. This one actually would travel a negative 260 degrees. So to get a coterminal angle, we are going to prefer our angles to be something between 0 and 360. So all we're going to do is add or subtract 360 to get to that point. I think I'm going to stop there and just pick up with that part tomorrow and do some examples of that. I am going to go ahead and give you some problems, but they are not due yet. So I'm giving you some problems because you have some time to work. You don't necessarily have to work on them as homework if you don't get them done in class, because tomorrow I'm going to finish this. I might start a little bit of the next section, and then I'm going to give you some class time to work as well. So these are not actually going to be due until today's Tuesday. Probably won't collect these until Friday, so you don't have to go home and do a bunch of homework. I'm just giving you some so you can get started while you have class time. So on page 7. Some of these are going to go pretty quickly. You could play 13 now.